Hi, my name is Shruti Vinod, and this is Lab Report 3 for Physics 2211. So, the purpose of this lab, and we have two parts here. The first one is finding the mass of the black hole, and we analyze the motion of a star where the mass is given to determine the mass of a black hole. The second part is to use the mass of the black hole that we derived from the previous part and to calculate the initial velocity of a given spaceship that intends to leave the gravitational field of the black hole and the planet orbiting the black hole. In the calculation loop, we are required to also calculate the forces on the planet and all the forces on the spaceship. So the main result of this lab is to demonstrate the effects of Newton's second law and its relationship with momentum. As you can see, these are my findings. So here are the main equations that we're using in this lab. We have Newton's second law, and these are the velocity update, the position update, and the net force, which is change in momentum over change in time. And we also have the parallel and perpendicular components of force, and so P hat and N hat, and we have the gravitational force, which is universal law of gravitation. So here's a visual representation of what is actually going on in this experiment. So now we have the free body diagrams. The first part is, we talk about the system and the surroundings, where the system is the star and the surroundings is a black hole in space. So we see the forces that are being exerted by the black hole and by the star. And in the second part, we see that there are two systems, which is the star and the planet, and the surroundings, which is a black hole and space. And we see all the forces that are being exerted by each one of these components. So in order to get a very accurate measurement for the mass of the black hole, we need to know how the momentum of the star is changing at multiple instances in its orbit around the black hole. And here we have the seed, which generates different values for each different person. And I've inputted the gravitational constant, mass of the star that was given, time interval, and how to calculate the velocity, which is both the x and y components. So here we see I've inputted different values on how to calculate initial final momentum, how to calculate the star's change in velocity, and net force to find both parallel and perpendicular net force. And I also ended up editing the arrows to represent the forces, as we can see in this model. So here are my results for FNet, FNet parallel, FNet perpendicular, and massive black hole, which was an average of all the values that I ended up getting. As we can see here, using the mass of the black hole from the previous model and inputting different constants, I will be using this to find the initial velocity of the spaceship, and I have inputted different values through trial and error for the initial conditions of the spaceship. So as we can see, we found first the net force on the planet, which includes the force of gravity on the planet by the black hole, force of gravity on the planet by the spaceship, and this is the net force on the planet. And then we found the net force on the spaceship, which includes force of gravity on the spaceship by the black hole and force of gravity on the spaceship by the planet. And then we apply Newton's second law and the position update formula to make the planet and the spaceship move. And we also added conditions to make sure that we have a way to understand just in case there's a crash, for example. And here are my results, and we also see the distance that the spaceship is away from the event horizon of the black hole. So possible errors that may have occurred is that the approximations or rounding values made during each iteration and related to the gravitational constant, because this is just a simulation and does not represent reality, and we are also assuming that there are no other outside forces acting on the system, and this could also explain the slight differences in the mass of the black hole at each iteration. Accuracy was also affected because I used trial and error to find velocities. So what does it mean? How is the net force and its parallel or perpendicular components different from the rate of change of momentum and its components? Mathematically, they're the same, but however, one of them is easier to measure. So for the net force, you need to know the individual outside factors exerting a force on the system. But for the rate of change of momentum, you just need to know the system's change in velocity or motion. What if? What initial velocity would your spaceship need to have in order to enter into some kind of orbit around the black hole? So compared to the initial velocity in part 2, the velocity to create an orbit should have a lesser magnitude in the x component and a greater magnitude in the y component. This would lead to an initial trajectory that is more vertical. So as we can see, this is my spaceship's velocity. So with this velocity, the spaceship orbits around the black hole with a trajectory shown to the left without hitting the planet. Thank you so much.